All right, we're taking a look at lesson 9.3, and we're going to be graphing a parabola that comes in a slightly different form than what we've been looking at. So it's going to be, we're used to just ax squared, so now there's going to be a plus something x, b will be a coefficient, and then even sometimes there'll be a plus c. So notice x is in these two spots, a, b, and c will be actual numbers. So there can be a coefficient to x squared, there can be a coefficient to x, and then there could just be like a plus 2 or plus 3 or something like that. So what do these parabolas look like on the graph? The big idea says graphs of any quadratic function with this equation, the one we're looking at where a is not 0, is a parabola, and the vertex can be found from the values of a, b, and c. So we're going to look at how do we do that. So no definitions, we're going to jump right in. Example number 1. The stopping distance of a car can be found using this formula. Distance equals 0.05 x squared plus x, where d is the distance in feet, and x is the speed in miles per hour. So you plug in for x in those two spots for how fast the car was going, and you can find out how long it's going to take that car to stop. What's the stopping distance? What's the fastest that car can possibly come to a stop? So calculate the stopping distance of a car traveling 55 miles per hour. So we're going to put that in for x, and we're going to find out what's d, what's the distance. So d equals 0.05. Instead of x, I'm going to go ahead and plug in 55 squared plus x again, 55. Okay, so it gets plugged in both spots. Now we have to follow our order of operations. So first thing I'm going to do is I'm going to do 55 squared. Bring in my graphing calculator here. Is 3,025. So I have to do that first, and then I'm going to times it by this. So I'm going to go ahead and write it out so that we remember exponents come first. So 0.05 times 3,025 plus 55. Okay, so we've done exponents. Now we're going to times that by 0.05. And we get 151.25. Still have to add 55. And we get 206.25. And that's your answer. So the stopping distance of a car, the fastest a car can stop, then it's going 55 miles an hour, is 206 feet, 0.25. All right, now let's go ahead to example 2. We're going to go ahead and graph this function. Okay, let's go ahead and do it in the calculator. So we're going to put this in x squared minus 2x plus 5. Take a look at the graph. And you can see we have a parabola, but it's no longer hitting at 0, 0. That's not the vertex. So we have a different vertex going on here. So we have to find that spot right there. So how do we do that? What we're going to do is we're going to go to the graph, which we're already here, and we're going to go ahead and use our calculate function. So you're going to hit second and trace, which gets us to that. And what we want to do is we want to find a minimum here, because if we go back to our graph here, the minimum of this is the vertex. Okay, so we're going to go to calculate, we're going to click minimum, and what happens is we have to click on the left of it and the right of it, and then the calculator will be able to figure out where the vertex is. So here's our left bound. Right bound now, we got to go on the right side of the vertex, so anywhere over here, hit enter. And then it says guess, so you go down close to it and you hit enter. And it's going to give you the value right here. Okay, so you can see we can round this off here. Y is 4 and x is 1. So the vertex is 1, 4. Okay, and you can find that in your table here too. So let's say you went to your table instead of your graph. If you look at all the values, as we're counting by ones, here's your middle point, 4. Then on both sides of it is 5, both sides is 8, both sides is 13. So that's right in the middle. 1, 4 would be your vertex. So your axis of symmetry is going to hit that. So let's go ahead and put this on the graph, and I think we can use that information to help us. So we're going to start at 1, 4. That's our vertex. And then as we go to the left to 0, it's up to 5. And if we go to the right to 2, it's also up to 5. And then on 3, it goes to 8. So 6, 7, 8. At -1, it should also be at 8. And then I don't know, it's 8, 9, 10, 11, 12. We could put 13 right at the top of the graph here. So -2 is going to hit at 13. And 4 is going to hit at 13. Okay, so there's your graph. Now, what's the axis of symmetry now? So we were used to it always being x equals 0. In this case, the line that goes through the vertex and cuts this in half hits at x is 1, and so that's the line x equals 1. All right, let's answer these questions. What are the x-intercepts? X-intercepts means hits the x-axis. Where does it hit the x-axis? Here's your x-axis. It does not, so the answer is none. There are no x-intercepts. What are the y-intercepts? Well, it's going to hit the y-axis right here. 1, 2, 3, 4, 5. That's 0, 5. And it's not going to hit it again, so that's the only one. Now going back, we haven't done domain and range in a while. Remember, domain are your x values and range are your y values. So what are all the x values here? So we've got all of these, but it's going to go forever in both directions. So if I keep going in the positives, eventually this function will hit every x value, and eventually it will hit every negative x value. Okay, so this is all real numbers. We've already done ones like this. It's going to go forever left to right. Now for the range, it's going to go forever up, but it's not going forever down. So we can't just write all real numbers. It's everything from here up. It goes on forever from here, but it never hits 3. This is 1, 2, 3, 4. So just remember how this looks. We're going to say y is greater than or equal to 4. It's from 4 up. Okay, let's flip it over. So I would have you try this, but there's some special things in here that we're going to have to kind of walk through. So what I want you to do, I want you to go ahead and plug this in your calculator, look at the table to help you make the graph, see if you can figure out the vertex and your axis of symmetry. Hold on your intercepts. We'll do those together. And see if you can do the domain and the range. So I want you to pause the video and try all that stuff. Leave out the x-intercepts and y-intercepts. If you want to try them, you can, but you may see why you need some extra help. I have to show you how to do something for those. So again, pausing the video, graphing this using the table, find out the vertex, axis of symmetry, domain, and range, and then come back to the video and see how you did, and then we'll walk through x and y-intercepts. All right, so let's plug this in. -2x squared plus 1. Take a look on the graph. You can see this actually is pretty close to 0, 0 for the vertex. Looks like it's just up 1. And if we go to our table, we can see 0, 1 is our vertex because from both sides here, it goes to -1, -1, -7, -7. So my vertex is 0, 1. Let's go ahead and put this on the graph. 0, 1 is right here. And then it goes to 1, -1, and -1, -1. So it's going down. Next, it goes down to -7. So 2, -7. So 1, 2, 3, 4, 5, 6, 7. Same thing here. 1, 2, 3, 4, 5, 6, 7. Mirror image on the other side. And that's the last one we're going to fit. And it goes down like that. Okay, so our axis of symmetry is right here. And it looks very similar to the ones we were studying in 9.1 and 9.2. Those hit 0, 0, but it was still the y-axis being the axis of symmetry. So it is here as well. And so we already know that equals the equation x equals 0. Let's skip the intercepts for a second. The y-intercept's pretty easy, but how do we do the x? That's the question. But let's look at the domain. We're at 0, and it's going to go forever to the right, slowly but surely. It will cover every positive x value, and it will cover every negative x value as well, starting from 0 down. It's going to continue forever. So our domain, which again are your x values, is all real numbers. But the range, while it goes forever down, it does not go forever up. This function will never hit any of these numbers up here. So it starts at positive 1 and it goes down. So we're talking about y. Y is less than or equal to 1, less than or equal to. Let's do the y-intercept. Pretty simple. It hits right here. So our y-intercept is at 0, 1, same as the vertex. But what are the x-intercepts? You can see it's going to hit in here between 0 and 1. So it's a decimal or a fraction. If we go back to the graphing calculator here and we hit graph, you can see it. If you kind of just float around, you can kind of get close to it, but you can't get right on it. So it's over there somewhere, like 0.7, 0.8, somewhere in there. And so if we go to calculate, there's a way to do this. So you go second, calculate, and what you're going to do is you're going to look for a 0, because where this hits, if you think about every intercept, for the y-intercept, the x value is 0, because it's not going to the right or left. It's hitting the y-axis, so the x is 0. Same thing is true in the opposite form for your x-intercept. Okay, it's not a negative y, it's not a positive y. Y is 0, and then x is something. So we're going to look for this 0. So go down to number 2. And same thing as before, you got to have a left bound and a right bound. So I'm going to look for this intercept first. Okay, so I'm going to click on the left side, which is where I'm at now. Then I have to scroll over and click on the right side of that intercept. And then your guess, you want to put that cursor pretty close to where it hits the axis. And it will figure it out for you. Here's the 0. When y is 0, x is 0.707. So 0.0, oops, not 0.0, 0.7. So 0.707. We're going to round it off, obviously. It's a big decimal, comma, 0. That's your x and y for this one. And now this should be the exact opposite, right? It always has a mirror on the other side. But let's go through this one more time and try it. So we're going to hit second. We're going to go to calculate. We're going to get the 0. Now left bound, if I want to find this intercept over here, I got to go to the left of it. Hit enter. Now right bound, so go to the right of it. Hit enter. And then where it says guess, go close to it. Hit enter. And there you go. It's now the negative version of what we had. So the other intercept is negative 0.707. So you have a couple new ways to find some stuff in here. All right, so you're going to really need to do as much work as you can in class, so you have the graphing calculator to help you. But in your textbook, a lot of the questions, they'll give you the graph, and it'll be pretty obvious. It won't necessarily be something you have to calculate through the graphing calculator. But ideally, they're going to help you more than you'd be able to do on your own without them. So try and get as much done in class as you can.